In this video, I'll show you how to inverse a matrix using the shortcut method. The steps to the shortcut method are listed below, and we'll follow these for questions 1 and 2. In question 1, we have a 2 by 2 matrix A, where we have 5, -2, 1, and 3. Step number 1 asks us to find the determinant of the original matrix. To find the determinant, we will find the product of the diagonal and subtract it to the product of the other diagonal. So let's take 5 times 3 minus 1 times -2. 5 times 3 is 15 minus -2, and this gives us positive 17. Step number 2 says interchange the elements on the main diagonal. So this right here is the main diagonal. We'll interchange their positions where we end up with A is equal to, and I'll write down A inverse because that's what we're trying to achieve, 3, -2, 1, and 5. Notice that I've only switched the 5 and the 3. Step number 3 says reverse the signs on secondary diagonal. So the secondary diagonal is this, and we have to reverse their signs. So this becomes negative, and this becomes positive. Lastly, divide every element of the original matrix by its determinant. And what this tells us is that we'll take this matrix, this 2 by 2 matrix, and maybe this is a little vague, maybe I shouldn't write down original matrix, and you multiply it by 1 over 17. So every element here will be multiplied by 1 over 17, and that's technically how you divide every element by the determinant. So we write down A inverse is equal to 3 over 17, 2 over 17, -1 over 17, and 5 over 17. Had you done this using the transformation method, you would have ended up with the exact same inverse, except it would have taken a lot longer. Usually when you see fractions in your elements, that means it would be more advanced coming up with the solution. And you can check if this solution is correct by multiplying this matrix by A. So technically, if you multiply A times A inverse, you should end up with your identity matrix of 1, 1, 0, and 0. Let's move on to question 2. Let's see if we've memorized the steps. The first step was to find the determinant. 1 times half minus 0 times 2, and this gives us simply half. That's our determinant. The next step was to change the diagonal, where we have A inverse is equal to 0.5, 0, 2, and 1. Next, we have to switch the signs of 2 and 0. Notice that 0 is already 0, so that stays the way it is. But 2 becomes -2. And the last step is to divide every element here by half. Let's go ahead and do that. This divided by 2, this divided by 2, this divided by 2, and that divided by 2 gives us 0.5 divided by 2 is a quarter, 0, -1, and half. That right there represents the inverse of this matrix. One more thing. If you had watched one of my previous transformation videos, I had used this exact same matrix. And in the transformation video, our answer was different than this. In fact, our answer was 4, 0, -2, and 1. The reason why that's different is because if I multiply this row 1 by 4, and row 2 by 2, then you would end up with 4, 0, -2, and 1. And you can do that. So it really depends on your teacher. Your teacher might not want fractions, and if that's the case, you'll have to do this last step. And so there you have it. That is how to inverse a matrix using the shortcut method.